What is the temperature now?
The temperature is 60 degrees Fahrenheit.
What is the volume of water in the swimming pool?
It's 40 cubic meters.
How far did John go? And in which direction?
John went 40 miles in north direction.
What can you infer from the three answers you gave above?
I see that for the first two answers, I needed to give only the number, that is, magnitude. But for the third question, I needed to give both number and direction.
That's correct. Quantities that can be described using a single number including any units are known as scalar quantities. For these quantities, only the size of the numbers matters, like 60 degrees Fahrenheit or 40 cubic centimeters, etc. Some other examples of scalar quantities are mass and time. While many quantities in physics are scalar, there are also many which are not, and for these quantities magnitude, that is number, tells only part of the story. For example, when I say the car traveled a distance of 5 kilometers, what can you infer from this data?
I understand that the car traveled 5 kilometers, but I don't know the direction. So all I know is that the car could be anywhere on a circle, whose center is the starting point, and whose radius is 5 kilometers.
Now when I say the car traveled a distance of 5 kilometers, in a direction of 30 degrees north of east, what information did you get extra?
I can now point the exact location of the car. I take 30 degrees from east towards north, and on this line, I travel 5 kilometers to exactly locate the position of the car.
A vector has both magnitude and direction. A vector quantity is a quantity that has both magnitude and direction, and thus can be represented with a vector. Vectors are represented graphically using arrows. By convention, the length of an arrow is proportional to the magnitude of the vector, and the direction of arrow gives the direction of the vector. So without knowing, you already had drawn a vector. In the example, the colored arrow which points from starting position of the car to its final position is the displacement vector of the car. Do you have any questions?
We see that the temperature can be positive and negative. Does this mean that temperature is a vector quantity?
The hallmark of a vector is that it has both magnitude and direction. Positive and negative temperature simply means that the temperature is greater than, or less than, 0, but it does not specify any direction. Therefore temperature is not a vector, it's a scalar quantity, and scalars can sometimes be negative too.
Okay, I got that.
We represent vectors with an arrow over a symbol, as shown. It is spelled as a bar. If we want to indicate only the magnitude of the vector, removing the sign and direction, we use the symbol as shown.